Hey everyone. In this video, we're going to be looking at the big ideas for section 4.4. And this is really a lot, it's just more vocabulary for experiments. So let's start off with this one. And we're going to look at our first vocab word, which is a control group. So a control group is used to provide baseline data to make comparisons. So a control group is not necessarily needed for an experiment, but if you want to compare to something, if you want to have a group to make a comparison to, then you should create a control group that really does not receive any kind of treatment. Most of the time, the control group receives a placebo, and then you compare the other groups that got a particular treatment back to that control group that got the placebo. So that's a control group. Next, we have a certain type of um, characteristic that we could give an experiment, and that is called blinding. So when we have any kind of blinding in an experiment, that means that either the test subjects are unaware of the treatment that they received, or both the test subjects and the experimenters themselves are unaware of what treatment was assigned. So if just, let's look at just single blinding. That means when the test subjects are unaware of what treatment they were assigned. They don't know, let's say they were taking pills. They don't know if the pill was a placebo or if it was a full dose or maybe it was a half of a dose, whatever it may be. If they don't know what treatment they were assigned, then that is called blinding or single blinding. Now, sometimes we don't want the test subjects to know what treatment they received, but we also do not want the experimenters to know what treatment each of the test subjects received. And that may be because if the experimenter knows that somebody received a placebo, it's possible that they may treat that particular test subject different than the other test subjects. So this would be called double blinding. If the test subjects don't know and the experimenters don't know, that is called double blinding. A common example of double blinding would be if a new experimental drug is being tested and they involve doctors in the experiment. Well, doctors usually will get paid more or be compensated more if the drug actually works. So if the doctor knows that patient A received a placebo and patient B received the real drug, they may treat patient A who got the placebo differently than patient B who received the real drug. And therefore, there might be a confounding variable that comes up because of that. So, this is why it would be important to double blind and keep the test subjects in the blind and keep the experimenters in the blind as well. Now, one last thing about double blinding somewhere it is recorded who got what treatment. But during the experiment, they don't know. All right, let's go to the next vocab word we have here, and that would be the placebo effect. So the placebo effect is when a fake treatment works. Okay, the fake treatment, which is the placebo, should not have any impact on the test subjects. But if it does have an impact, and it should not, that means the placebo effect has occurred. The last thing that we're going to look at today are four key principles of experiments. So these four things that we're about to show are four characteristics that must be a part of any good experiment. So let's start with the first one, and that would be comparison. So we always have to have something to compare to, whether we have a control group that gets a placebo or some other group, but we have to have some kind of comparison. So there must be at least two different treatments even if one of those treatments is a placebo, there must be two different treatments in order to make any kind of comparison. All right, what about the second characteristic? Well, that would be random assignment. Now, one of the big things to keep in mind is this. You do not randomly choose your test subjects. In an experiment, you do not randomly choose the test subjects, but you do randomly assign the treatments to the test subjects. So there must be a chance or random process of assigning the treatments to the experimental units. So in a survey, you randomly choose the people that you survey. But for an experiment, you don't randomly choose the people. Once you have the people or the test subjects or the experimental units, then you randomly assign the treatments to those experimental units. The third characteristic of a well-designed experiment is control. Now, that does not mean that we have to have a control group. This is a different type of control. We are controlling the variables. So we need to keep all other variables besides the treatments constant. Okay, keeping all the other variables constant is going to help us isolate the treatments. And if the only difference between our experimental units are the treatments, it gives us better results. So we need to control the variables. And then finally, the last characteristic of a well-designed experiment is replication. You need to make sure that you use enough experimental units to distinguish differences. Replication means that you need to repeat the experiment for multiple experimental units. If we only had 2 experimental units, that's not enough to distinguish any differences. So replication means that we need to repeat this experiment on multiple experimental units in order to distinguish differences. So there we have it. Those are the big ideas for section 4.4. A lot of vocabulary. This entire unit is all about vocabulary. So you need to make sure that you really are memorizing these definitions and having a strong understanding of each one. Have a great day.